Welcome back to InfoStock. Disclaimer: this video is for educational purposes only and is not investment advice. Always consult with a qualified financial advisor before making any investment decisions. Past performance does not guarantee future results. Last week, we broke down 3 stocks, crushing it in the AI boom: Micron, NVIDIA, and Palantir. But here's what most people miss: those companies are only winning because of what's happening behind the scenes at Amazon, Microsoft, and Google. Right now, 3 companies are in the most expensive arms race in tech history, and they're spending more money than you probably think is possible. We're talking about $600 billion in AI data center buildouts just in 2026. In this video, we're breaking down who's winning, what they're building, and what it means for the stocks we talked about last week. Let's put this in perspective. The top 4 hyperscalers, Amazon, Microsoft, Google, and Meta, are projected to spend approximately $600 billion on capital expenditures in 2026 alone. That's up 36% year over year from 2025. To give you context, that's more than the GDP of most countries. And almost all of that money is going to AI infrastructure. Here's the breakdown. Amazon is expected to spend around $125 billion or more. Microsoft is projected to hit $121 billion. Google is investing $85 billion minimum. Meta is committing $70 billion. And that's just these 4. When you add Oracle and Apple, you're looking at an ecosystem spending close to $750 billion annually on AI data centers. Why? Because of a simple economic reality. Demand for AI computing is outstripping supply by a massive margin. Amy Hood, Microsoft's CFO, said it directly during earnings. "We've been short on computing power for many quarters. Demand is increasing. We are not catching up." That's the CFO of a $4 trillion company, saying they can't build data centers fast enough. If Microsoft is behind, that tells you everything about the intensity of this race. The supply crunch comes down to one thing: Blackwell GPUs. Remember from last week, NVIDIA Blackwell chips are sold out. But here's the actual number that shocked the market. The top 4 hyperscalers ordered 3.6 million Blackwell units just in the first quarter of availability. Meta alone is ordering 1.3 million units. That's not a rounding error. That's a commitment worth tens of billions of dollars. Why are they buying so aggressively? Because building frontier AI models and deploying them at scale requires immense compute power. A single large language model training run can require thousands of GPUs running continuously for weeks. A data center that supports millions of concurrent AI inference requests needs redundancy, diversity, and massive compute throughput. But here's the problem. Even with NVIDIA ramping Blackwell production at record speed, demand still vastly exceeds supply. Morgan Stanley research indicates a 12-month backlog on Blackwell orders. That means hyperscalers ordered chips in January 2026 that won't be delivered until January 2027. So, what do they do while they wait? They keep buying older generation chips like NVIDIA's H100 at premium prices. This is why Micron's high-bandwidth memory revenue is surging, and why NVIDIA's data center margins remain so strong. The supply crunch is actually enriching the entire semiconductor ecosystem. But there's another constraint nobody's talking about: power. Building a data center that can support massive AI training and inference requires enormous amounts of electricity. A single hyperscale AI data center facility can consume 100 megawatts or more. The biggest facilities are pushing 500 plus megawatts. That's the equivalent power draw of a small city. Amazon announced a $50 billion investment to build 1.3 gigawatts of capacity for U.S. government customers alone. That's just the government segment. Microsoft is facing similar power crunches and is investing in on-site power generation. Google is doing the same. This creates a massive constraint on where data centers can be built. You can't just build them anywhere. You need access to abundant, reliable power. You need water for cooling. You need fiber optic connectivity. And you need to be geographically distributed not just for redundancy, but for latency. If you're running an AI inference service for millions of users, you need data centers close to those users. That's why you're seeing hyperscalers build data centers in India, Japan, Europe, and throughout the United States simultaneously. This geographic constraint actually creates opportunity for Palantir because helping enterprises deploy and manage distributed AI infrastructure across multiple regions is a core Palantir use case. So who's winning this race? That depends on how you define winning. Amazon has the most mature cloud infrastructure and the longest history. Microsoft has OpenAI's backing, which gives them massive partnership leverage. Google has Gemini and a history of building incredible AI models. Meta is spending the most aggressively relative to their historical CapEx, betting that AI will unlock new revenue streams. But here's the critical insight: they're not competing directly on chips. They're competing on integration. Amazon has AWS, Microsoft has Azure, Google has Google Cloud. These platforms bundle compute, memory, storage, networking, and AI services together. The company that can offer the complete stack most efficiently wins. This is where things get interesting for 2026. All four are investing in custom chips. Amazon has Trainium chips for training and Inferentia chips for inference. Google has TPUs. Microsoft has partnerships with AMD and custom silicon plans. Meta is developing custom silicon through partnerships. Why? Because building your own chips lets you optimize the entire system hardware and software together to maximize efficiency. NVIDIA's Blackwell is powerful and flexible, but a custom chip designed for your specific workloads can be 20 to 30% more efficient. When you're operating at hyperscale, even 5% efficiency gains save hundreds of millions of dollars annually. Now here's where this connects back to Episode 1. This hyperscaler spending doesn't just benefit NVIDIA. It cascades through the entire supply chain. Micron supplies high-bandwidth memory to support GPU training. Palantir's software helps enterprises actually use the compute. These hyperscalers sell. Companies like CoreWeave are building specialty data centers just to resell GPU capacity. From hyperscalers to startups and enterprises that can't get direct NVIDIA allocation. Think about the economics. Hyperscalers are buying so many chips that they can't use them all for their own services immediately. So they lease excess capacity to other companies. CoreWeave, a startup backed by NVIDIA, just signed an $11.9 billion contract with OpenAI to provide GPU infrastructure over 5 years. Nebius Group, another data center provider, signed a $17.4 billion deal with Microsoft. These aren't small deals. These are billions flowing to infrastructure providers. Because demand is so constrained that even third-party data center resellers can command premium pricing. And this all cascades back to memory, networking, and storage providers. Hyperscalers need high-speed interconnects, specialized memory, and massive storage systems. Every dollar spent on compute drives, spending on the entire peripheral ecosystem. What does 2026 actually look like? First, hyperscaler CapEx continues climbing. All four are guiding for increases, not decreases. Microsoft's CFO said CapEx growth in fiscal 2026 will be even higher than 2025. That means we're looking at potentially $650 billion or more in combined CapEx from just the top four. Second, the power constraint becomes the binding limitation. You can design great chips and build great software, but if you don't have power, you can't build the data center. This is why Stargate, the $500 billion AI data center project, announced by SoftBank, OpenAI, and Oracle, is such a big deal. It's explicitly designed to solve the power constraint. Third, the supply of Blackwell gradually loosens, but demand continues to exceed supply. By mid-2026, the shortage eases slightly. But it takes until 2027 before true supply-demand balance appears. This means prices stay elevated and semiconductor suppliers stay profitable. Fourth, edge data centers become critical. Hyperscalers realize you can't run everything from centralized hubs. They need distributed AI compute closer to users for inference workloads. This creates a second wave of data center build-outs. Palantir's software becomes even more critical here, because managing inference workloads across hundreds of distributed facilities is a nightmare without proper orchestration. Bottom line, the data center arms race doesn't end in 2026. It accelerates. So here's what this means for the stocks we covered last week. Micron stays profitable because hyperscalers can't get enough memory fast enough. NVIDIA's data center business stays on fire because every facility these companies build needs thousands of GPUs. Palantir's enterprise software becomes increasingly valuable. As companies try to actually use the AI infrastructure these hyperscalers are building. If you found this breakdown valuable, make sure you hit subscribe and the bell icon so you don't miss the next InfoStock episode. We're diving deeper into the AI supercycle every week. Thanks for watching, and I'll see you in the next InfoStock video.